A very good evening to everybody. And today, on the occasion of International Rock Day, we have a renowned geologist who is going to talk to you about the International Rock Day, especially about one of the rare and valuable metals which comes between the rocks. This is one of the initiatives of Bharat Scouts and Guides Karnataka, continuing its digital engagement of Scouts, Guides, Rovers, and Rangers. This comes part of the brainchild of Sri P.J.R. Sindhya sir, who is the State Chief Commissioner of Karnataka. He is going to introduce today's speaker of the day. Now I call upon Sri P.J.R. Sindhya sir to introduce the guest of the day.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good evening to everybody, people from Karnataka and all over the country. We are all observing the International Rock Day today all over the world. It's a very important event in the world. On this occasion, during the period of this pandemic, coronavirus, we have been keeping people informed in many ways. As all of you know, Scouts and Guides is a youth movement in the world and in the country. And particularly in Karnataka, we thought that we should keep our teachers, our students, Scouts, Guides, Rovers, Rangers, Scout leaders, Guide captains, Rover leaders, Ranger leaders, and other senior leaders engaged, and to know the importance of the International Rock Day. When our state committee, Mr. Khalid, Mr. Geeta Nataraj, Mr. Shanmugappa, and all our senior leaders, we thought that on the occasion of this International Rock Day, we will have Dr. V.N. Vasudev with us. Dr. V.N. Vasudev has been a good friend of Scouts and Guides. He is a supporter of Scouts and Guides. He believes in the development of the youths. He has been doing a wonderful work as far as the youth movement is concerned. Dr. Vasudev ಅವರು ಬಹಳ ದೊಡ್ಡ ಹಿನ್ನೆಲೆಯಿಂದ ಬಂದಿರತಕ್ಕಂಥ ಒಬ್ಬ ನುರಿತ ವಿಜ್ಞಾನಿಗಳು. He is a great scientist in earth sciences, particularly in the field of gold and minerals. ಡಾಕ್ಟರ್ ವಾಸುದೇವ್ ಅವರು ಅತ್ಯಂತ ಪ್ರತಿಭಾನ್ವಿತ ವಿದ್ಯಾರ್ಥಿಗಳಾಗಿದ್ದರು. ಅವರು was a very brilliant student during his student days. He has an excellent academic career. He got his PhD from the Indian Institute of Science, Bangalore, which is the pioneering institute as far as the sciences are concerned in India and also in the world. ಮಾನ್ಯ ವಾಸುದೇವ್ ಅವರು ಇಂಡಿಯನ್ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಆಫ್ ಸೈನ್ಸ್ ಬೆಂಗಳೂರಿನಲ್ಲಿ PhD ಪದವಿಯನ್ನು ಪಡೆದಿರತಕ್ಕಂಥವ್ರು. ಕರ್ನಾಟಕ ಸರ್ಕಾರದಲ್ಲಿ ಮೈನ್ಸ್ ಅಂಡ್ ಜಿಯಾಲಜಿ ಭೂವಿಜ್ಞಾನ ಇಲಾಖೆಯಲ್ಲಿ ಸೀನಿಯರ್ ಜಿಯಾಲಜಿಸ್ಟ್ ಆಗಿ ಸ್ವಲ್ಪ ದಿನಗಳ ಕಾಲ, ಕೆಲವು ವರ್ಷಗಳ ಕಾಲ ಕೆಲಸ ಮಾಡಿದ್ದಾರೆ. He has served as a senior geologist in the Department of Mines and Geology in the Karnataka government. After his retirement in 2016, he has devoted all his life for the public cause. In fact, he has been working for the public for the last several years. He has a vast experience. He has gone around the world, almost all the continents he has gone around. I am surprised that he has toured more than 49 countries and attending seminars, symposiums, lectures, and all these things. And in fact, very few people in this country have gone to Greenland and Iceland, both. That is something which is very, very difficult to get such people. These days, he has been spending his time in writing, lecturing, and he is helping the government of India in making a national mineral policy. He has been helping, he has been in touch with the bureaucrats of the government of India and also the other leaders of the government of India, and he has been recommending. In fact, I know Dr. Vasudev almost for the last 30 to 40 years. His father was a great saint. He was a disciple of Dattatreya. Dattatreya is Brahma, Vishnu, Maheshwara. All these three gods make one Dattatreya. His father, Swami Sahajananda, was a great saint, great saint. He devoted all his life for spreading humanism in this place. I met him for the first time, must be around 40 years back, in a place called Dodda Muduvadi in Kanakpura Taluk, presently Ramnagara district, where he blessed me. Till his last, he was with me, and I consider even today, his blessings are with me. He was preaching Dattatreya philosophy. Dr. Vasudev comes from that family, and all the members of his family, including his wife, they are all devotees of Dattatreya. Dattatreya is a very secular god, one should know it. That's only for humanity. And now, other than all these things, other than knowing about minerals and teaching, and other than participating in the policy making, he has started an organization called Sacred Trust some 20 years back. And this Sacred Trust has been doing a wonderful job in the rural areas for the needy and the poor students. I am also surprised. He has given IT education, computer training at his cost, free of cost, to 36,000 youngsters of Ramnagara districts and other districts. Hats off to you, Dr. Vasudev. I am really surprised. ನಂಗೆ ಭಾರಿ ಸಂತೋಷ ಆಗಿದೆ. 36,000 ಜನಕ್ಕೆ IT ಶಿಕ್ಷಣವನ್ನ ನಿಮ್ಮ ಸೇಕ್ರೆಡ್ ಟ್ರಸ್ಟ್ ಇಂದ ಖರ್ಚು ಮಾಡಿ ಹಣವನ್ನು ಕೊಟ್ಟಿದ್ದೀರಾ. ನಮ್ಮ ಭಾರತ್ ಸ್ಕೌಟ್ ಗೈಡ್ಸ್ ನ ಸ್ನೇಹಿತರು ನೀವು. ನಮ್ಗೆ ಇತ್ತೀಚೆಗೆ ಭಾರತ್ ಸ್ಕೌಟ್ ಗೈಡ್ಸ್ಗೂ ಸಹಿತ ನಿಮ್ಮ ಸಹಜಾನಂದ ಸೇಕ್ರೆಡ್ ಟ್ರಸ್ಟ್ ಇಂದ 4 ಕಂಪ್ಯೂಟರ್ಗಳನ್ನ ನಮಗೆ ಕೊಟ್ಟಿದ್ದೀರಾ. ನಾವು ಇದಕ್ಕೆ ತುಂಬಾ ಆಭಾರಿಯಾಗಿದ್ದೇವೆ. ನಾವು ಇದನ್ನ ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಕ್ಕೆ ಪ್ರಾರಂಭ ಮಾಡಿದ್ದೇವೆ ನಮ್ಮ ಹೆಡ್ ಕ್ವಾರ್ಟರ್ಸ್ ಅಲ್ಲಿ. ಈ ಕರೋನಾ ಪೀರಿಯಡ್ ಅಲ್ಲಿ ಎಲ್ಲವೂ ಸಹಿತ ವರ್ಚುವಲ್ ಆಗಿ ಮಾಡ್ತಕ್ಕಂಥ ಒಂದು ಸಂದರ್ಭ ಬಂದಿದೆ. ನಿಮ್ ಕಂಪ್ಯೂಟರ್, ನಿಮ್ ನಾಲೆಡ್ಜು ನಮಗೆ ಬೇಕು. ನಿಮ್ ಸಹಕಾರ ಮುಂದಿನ ದಿನಗಳಲ್ಲೂ ಸಹಿತ ಬೇಕು. ಪ್ರಪಂಚವನ್ನೇ ನೋಡಿರ್ತಕ್ಕಂಥವ್ರು ನೀವು. ಸ್ಪಿರಿಚುವಲ್ ಆಗೂ ನೋಡಿದ್ದೀರಾ, ಪ್ರಾಕ್ಟಿಕಲ್ ಆಗೂ ನೋಡ್ತಾ ಇದ್ದೀರಾ. ಮುಂದಿನ ದಿನಗಳಲ್ಲಿ ನೀವಿನ್ನೂ ಎತ್ತರಕ್ಕೆ ಹೋಗಿ ಕರ್ನಾಟಕದ, ಭಾರತದ ಕೀರ್ತಿಯನ್ನ ಅಂತಾರಾಷ್ಟ್ರೀಯ ಮಟ್ಟಕ್ಕೆ ತೆಗೆದುಕೊಂಡು ಹೋಗಿ. ಬಹಳ ಮುಖ್ಯವಾಗಿ ಬೆಲೆ ಕಳ್ಕಳ್ದೇ ಇರೋದು ವಸ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಚಿನ್ನ. ಚಿನ್ನ ಬೇಡ ಅನ್ನೋರು ಯಾರಿದ್ದಾರೆ? ಮಕ್ಕಳಿಗೆಲ್ಲ ಚಿನ್ನ 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 ಅಂತ ಕರೀತಾರೆ. ಅಂದ್ರೆ ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಚಿನ್ನ ಬೇಕು ಅಂತ ಹೇಳಿ. ಚಿನ್ನ ಹೇಗಾಗುತ್ತೆ ಮತ್ತು ಯಾವ ರೀತಿ ಆಗುತ್ತೆ, ಎಲ್ಲೆಲ್ಲಿ ಸಿಗ್ತದೆ, ಇಂಡಿಯಾದಲ್ಲಿ, ಕರ್ನಾಟಕದಲ್ಲಿ, ಇದೆಲ್ಲ ತಿಳ್ಕೊಂಡಿರೋರು ನೀವು. ಜೀವನನೇ ಕೊಟ್ಬಿಟ್ಟಿದ್ದೀರಾ. ಈಗ ದಯಮಾಡಿ ಸಾವಿರಾರು ಜನ ನಮ್ ಸ್ಕೌಟ್ ಗೈಡ್ಸ್ ಮಕ್ಕಳು ಬಹಳ ಶಿಸ್ತಿನ ಮಕ್ಕಳು ಇವರು. ಇವರೆಲ್ಲ ಕರೋನಾ ಸಂದರ್ಭದಲ್ಲಿ ಸರ್ಕಾರದ ನಿಯಮಗಳನ್ನ ಬಹಳ ಚೆನ್ನಾಗಿ ಪಾಲಿಸ್ತಾ ಇದ್ದಾರೆ. ಅದ್ರ ಜೊತೆಗೆ ಸೇವೆ ಬಹಳ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. 25 ಲಕ್ಷ ಮಾಸ್ಕ್ಗಳನ್ನು ಮಾಡಿ ನೀಡಿ ಪೀಪಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ. SSLC ಎಕ್ಸಾಮಿನೇಷನ್ ಸೆಂಟರ್ಗಳಲ್ಲಿ ಸರ್ವಿಸ್ ಮಾಡಿದ್ದಾರೆ. SSLC ಹುಡುಗರಿಗೆ 9 ಲಕ್ಷ ಜನಕ್ಕೆ ಮಾಸ್ಕ್ಗಳನ್ನ ಫ್ರೀ ಆಗಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಾವಿರಾರು ಜನ ಸ್ವಯಂ ಸೇವಕರಾಗಿ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಈ ಸಂಸ್ಥೆಗೆ ತಾವು ಬಂದಿರೋದು, ತಾವು ಯಾವಾಗೂ ನಮ್ಮ ಸ್ನೇಹಿತರು. ಇವತ್ತು ಈ ಸಂದರ್ಭದಲ್ಲಿ ಅನೇಕ ನಮ್ಮ ಜಿಲ್ಲಾ ಮುಖ್ಯ ಆಯುಕ್ತರುಗಳು, ಜಿಲ್ಲಾ ಪದಾಧಿಕಾರಿಗಳು, ತಾಲೂಕ್ ಪದಾಧಿಕಾರಿಗಳು, ರಾಷ್ಟ್ರ ಮಟ್ಟದ ನಾಯಕರುಗಳು, ನ್ಯಾಷನಲ್ ಲೀಡರ್ಸ್, ಆಲ್ ಆಫ್ ದೆಮ್ ಆರ್ ವಾಚಿಂಗ್ ದಿಸ್ ಆನ್ ಫೇಸ್ಬುಕ್. ಐ ಎಕ್ಸ್ಟೆಂಡ್ ಎ ವಾರ್ಮ್ ವೆಲ್ಕಮ್. ಬಹಳ ಪ್ರೀತಿಯಿಂದ, ಗೌರವದಿಂದ, ಅಭಿಮಾನದಿಂದ ನಿಮ್ಗೆ ಈ ವೆಬಿನಾರ್ಗೆ ನಾನು ಸ್ವಾಗತ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಇದಕ್ಕೆಲ್ಲ ನಮ್ಮ ರಾಜ್ಯದ ಎಲ್ಲ ನಮ್ಮ ಪದಾಧಿಕಾರಿಗಳು ನಿಮ್ಗೆಲ್ಲರೂ ಗೊತ್ತಿದ್ದಾರೆ. ಗೀತಾ ನಟರಾಜ್, ಕಾಳಿ, ಷಣ್ಮುಗಪ್ಪ, ಗಂಗಪ್ಪಗೌಡ, ಬಸವರಾಜ್, ಎಲ್ಲರೂ ನಿಮ್ಗೆ ಗೊತ್ತಿರೋರೆ. ರಾಮ್ಲತಾ ಎಲ್ಲ ನಮ್ಮ ಅಧಿಕಾರಿಗಳು ಗೊತ್ತಿದ್ದಾರೆ. ಮತ್ತೆ ಇದಕ್ಕೆಲ್ಲ ನಮ್ಮ ಮಧುಸೂದನ್ ಅವರು ಈ ತಂತ್ರಜ್ಞಾನವನ್ನು ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಕ್ಕೆ ನಮ್ಗೆ ಬಹಳ ಅವ್ರು ಇಲ್ಲದೆ ಹೋಗಿದ್ದಿದ್ರೆ ನಾವೇನು ಮಾಡಕ್ ಆಗ್ತಾ ಇರ್ಲಿಲ್ಲ. ಅವ್ರ ಸಹಕಾರನ ನೆನ್ಸ್ಕೊಂಡು ಇವತ್ತು ನಿಮ್ಮ ಒಂದು ಪ್ರೆಸೆಂಟೇಶನ್ ಅನ್ನ ಪ್ರಾರಂಭ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿ I request you to kindly go ahead with your presentation. I once again extend a warm welcome to you to this webinar, sir. Thank you.
Thank you very much, sir. I'm very grateful to Bharat Scouts and Guides, and particularly to you, sir, PGR Sindhyaji, most respected Commissioner of Bharat Scouts and Guides, and Mr. Madhusudan. And this is a great opportunity for me to share my knowledge of the earth sciences. It's and rocks and minerals on this auspicious International Rock Day. In fact, I should say I was not aware of international. It is, 13th today is the International Rock Day. Was told to me by yourself, Mr. PGR Sindhya ji. I was not aware. Thank you very much. And then you also invited me on the same to share my knowledge on this one. Without taking much time, I will straight away go to the topic of the day. And I wish to talk on the evolution of the Earth, the very beginning of the Earth, and the geological history of the continents, how they formed, and how the rocks formed, the minerals originated, and especially, my pet subject, how gold formed in the Earth's crust. And then let me begin with the universe, because that is the beginning of the Earth, goes back to the beginning of the very universe itself. So let's touch upon universe, the galaxy, the solar system, the Earth. The Earth started at around 4.5 billion years. And I'll explain a bit about the structure of the Earth, how from surface to the core of the Earth, how it's composed of, what are the layers. And I'll talk about volcanic eruptions, earthquakes, and metal deposits, how they are distributed in the Earth. It will take about 1 hour, probably 1 hour, 10 minutes. And there will be some time for question and answer, I understand. Yeah. Universe began 13.7 billion years ago. This is a diagrammatic representation. I think it was probably prepared by Professor Stephen Hawking, one of the authorities on how the universe began. And on the left-hand side here, you will see this is the beginning here. This is the one, and these are different. These lines represent 1 billion years. There are nearly 13 such lines representing 13 billion years here. It all started with a Big Bang. What is the original material which triggered the Big Bang? Really, nobody knows. Nobody knows so far. In the Vedas say that in the beginning of the universe there was nothing. That means Vedas say that the universe began from nothing. The scientists, they are yet to find out what was the beginning material. Anyway, let's not so much worry about that. The whole thing began 13.7 in an event called a Big Bang, and the universe started inflating, going, expanding, exponentially expanding. And then at some point of time, around 5 billion years ago, our galaxy formed. Let's go to the galaxy. This is a part of the galaxy here. Each dot in this image is an entire galaxy. There are about 100 billion galaxies in the observable universe. And each galaxy contains up to trillion stars. You can imagine the magnitude of the universe. It's so huge, which we can't even imagine. And there are about 10,000 galaxies, and each galaxy has stars. And one of the stars is our sun. This is the galaxy. This is called the Milky Way galaxy. This is where our solar system is there. There are billions of stars within the Milky Way galaxy. The Earth is a tiny part of our solar system. In fact, the solar system itself is a very tiny part of our galaxy. That is the vastness of this universe. Now here, how did the solar system and the planets formed? Solar system formed due to the revolution, a revolving mass of gases. It gave rise to the planets and the solar system. It's a very intricate subject. In fact, my knowledge itself is how it all began is very limited. Suffice to say that in a centrifugal force, the material started consolidating and the planets formed. Look at this one. The third planet from the sun is the Earth. It's about 1.5 lakh kilometers away from the surface of the sun. This is the distribution, and this is the Earth. This is the Earth that's photographed from the surface of the moon. So if you stand on the moon, this is how you look at the Earth. So about 12.7 kilometer is the diameter of this Earth. Let's look at the structure of the Earth now. Okay, so the Earth is density stratified. What does it mean? It means, in simple words, on the surface we have lighter materials. What we see, for example, in Bangalore, we see granite. It's relatively lighter material compared to the very dense, high-density materials constituting the different layers of the Earth and the core of the Earth. Let me take you through. This is the cross-section here. The radius of the Earth is 6,400 kilometers from surface to the center. Surface, as I said, the crust of the Earth, we call it as the crust of the Earth. It's about 2.2 to 2.9 is the density, as compared to almost 13 density of the Earth, which is the center of the Earth is constituted of solid iron 85% and nickel alloy, sulfur and oxygen. That is this one. This is a solid one, but the outer core is a liquid one, and relatively lighter materials constitute the entire Earth surface. Earth, this is the one. And all that human beings are concerned is just about the first 5 kilometers. All our activities are concerned with the first 5 kilometers on the surface of the Earth. Of course, the scientists have touched the deepest part of the oceans, which is more than 10 kilometers. That is the deepest point that has been explored by scientists. So this is the structure of the Earth. Now, how the first continents formed. When the Earth formed, the surface was all completely covered. When the whole Earth cooled from high temperatures to the, less than boiling temperatures, the surface was covered entirely by water. The first vapors went from the Earth itself. So whatever volcanism sent out oxygen among other metals, other minerals, other elements, I should say, oxygen, nitrogen, carbon dioxide, carbon monoxide, and hydrogen went into the surface, and the first clouds were formed due to the vapor that went out through the volcanism and the cooling of the very Earth itself. So the first clouds formed at around, say, 4.5 to 4.5 billion years ago. That's by the time the Earth had completely solidified. Yeah, let's look at the formation of the continents. Without the continents, we don't have the minerals. Yeah, this is how the crust here was completely covered by water, and here also water. Here and there was thickening of the crust started. Thickening in the sense, the vestiges of the very beginnings of the continental crust began here and there. That is due to the volcanism. Look at this surface here. This, as I said, the Earth is layered. The topmost layer is the oceanic crust and the continental crust. Let's look at how this continent formed. There are two types. Due to heavy volcanism, the volcanic rocks formed on the surface of the Earth and came out of the water bodies. Then ocean, it popped up the surface. Here it is, for example. The rest of the ocean floor, due to what is called the geodynamics, the subducting we call, or going beneath the continents. I'll explain to you after a few minutes how the Himalayas began. You will understand what I mean by the subduction. So subduction of a layer or a plate, we call geological plates, the ocean plate subducting beneath the continental plate. This original continent was completely composed of, not like today here, it was completely composed of what we call as basalts and felsic volcanic rocks. Suffice to say, volcanic rocks entirely. Later on, the other kinds of rocks like granites came into being. So all these things began around 4.2 to almost 3.5 billion years. We have the evidences, the most ancient rocks of 4.2 billion years have been sampled in parts of Australia and even in India, in parts of Jharkhand. And the oldest rock known in Karnataka is from Gorur in near Holenarsipur, that is dated at 3.5 billion years. For those who are not familiar with the billion years, 1 billion year is equal to 100 crore years. 100 crore years is 1 billion year, or 1 billion year is equivalent to 1,000 million years. So this is how it is. So the Earth began 4.5 billion years. The first rocks began around 4.2, and most of the rocks that we see, the oldest rocks that we see, are around 3.5 billion years and younger. Right. So now look at this one. Due to the subduction of the sea floor or the ocean floor, the volcanism began, and this is the reason, the volcanism is the reason for all the metals that we see on the surface of the earth. Everything came through volcanoes. Yeah. Now, continents have been growing in their size. Once the small continents, we call it as microcontinents, when it began around 3.5 billion years ago, and they started gathering mass and growing, slowly growing, and even today the continents are forming. Even today it's forming and moving. The movement of the continents and oceans, as I said, is due to the geodynamics of the earth. What is happening below, around 60 to 100 kilometers below the surface of the earth, there's a movement that is taking place. That's the reason surface continental plates, oceanic plates also move. Okay, so this is the style of movement that's happening. India is moving this way. The continent of Africa and Southern America are moving apart, and due to the movement, we have the Atlantic Ocean here, and this is the Pacific Ocean is subducting or going beneath the South and North America. So several times this has happened. The last time that has happened, the continents were together around 125 million years ago. The southern portions were all called India, Australia, the Africa, and Southern America. These are all called, and also Antarctica. These are called Gondwana land. Okay. Now, how did the Himalayan mountain, after explaining these movements and the formation of the hills and valleys, a more interesting subject of how the minerals that we use day to day, they all originated. Okay, now look at this one here. After the formation of the Gondwana land here, the drifting continued to take place. The drifting in the sense movement. Let's look at the movement of India. India started moving towards the Asia here. From the current location of the southern, the Antarctica, that's where the India was around 100 million years ago. It started moving towards the Asia, and it is about 9,000 kilometers from where it was around 100 million years ago to where it is today. It's 9,000 kilometers. This is how the India moved towards the Eurasian plate or the Asian plate here. This is the place we see the Himalayan mountain ranges, vast Himalayan mountain ranges, and the Tibetan plateau and the China. Yeah. So this took nearly around 90 million years to travel 9,000 kilometers at the rate of 5 centimeters, 16 to 5 centimeters. Even today, India is moving at the rate of 5 centimeters towards the Himalayas, and particularly northeastern Himalayas. That is the reason why in the northeast part of India, we have the loftiest mountains. That is the Kanchenjunga, the Mount Everest, or the Gauri Shankar Shikhara. They are in the northeastern part of India because India is moving and abutting against the Tibetan plateau. Yeah. Continents, what are they made up of? They are made up of what we call as igneous rocks or Agnishilegalu, they call. Sedimentary rocks or Jalajashilegalu. And metamorphic rocks, that means Rupantarikruta, that means the modified forms of igneous and sedimentary rocks. So igneous means it is crystallized from molten rock. Molten rocks, two kinds of molten rocks. One that comes out of a volcano, the other one which solidifies inside the surface of the earth. They are called magmas, which once it comes out through volcanoes, they are called lavas. The composition, different compositions are there. I'll come to that. So igneous rocks are crystallized from the molten matter. Then the magmas that extruded out of volcanoes, they are called volcanic rocks. Sedimentary rocks are those which are formed in large bodies. It need not be very large. Large means ocean. Those which were deposited in oceans and the large lakes and small lakes, and even in what we call as tanks or kere, sedimentation is taking place, and they may give rise to solid rocks in the future. So that's how in the early history of the earth, the sedimentary rocks began, and I will show photographs of these rocks. Metamorphic rocks. Metamorphic rocks are those which, as I said, formed due to the by subjecting the igneous and sedimentary rocks, the metamorphic rocks formed. Subjecting in the sense, subjected to pressure and high temperatures, the metamorphic rocks took birth. And I will show some of the pictures of some of these rocks now. Yeah, this is the igneous rock. This is a typical granite. This is a photograph of the Chitradurga hills. We call them as granites. Granites are quite common in many parts of India, and there are so many examples. For example, the what we call as the close spread granite spreads from almost Kanakpura in the south to almost Hungund or Kustagi beyond Malkalmuru, Bellary. That's the whole range for nearly 350 kilometers. The whole range of granites exist, and they are formed around 2.6 billion years ago or 260 crore years ago. So there are Chamundi hills, for example, the Kolar side granites. They're all granites which all formed around 2.5 to 2.6 billion years ago in Karnataka state. So these are formed around, because they are crystalline rocks, they solidified around 3 to 4 kilometers below the surface. How do you see them at the surface now? How do you see them? That's because the surface of the earth is, over the period of last almost 300 to 250 crore years, it's all completely stripped off. It's all getting eroded due to the sun and rain. Rainfall, whenever there is a rainfall, it takes particles of rocks into the ocean, into the streams, lakes, and oceans, like that. This is at, the most famous, the granites, the Hampi area, and between near Hospet or between Bellary and Hospet. Whole range of granites are there. And these are carved out of the Hampi granites. They are also 250 crore years ago. These are some of the rocks which are seen near Mudugal. Now you see these beautiful systematic the joints here, horizontal set of joints, vertical joints. There are two sets of vertical joints, both one crossing each other, and that's the reason how the boulders form here. If there were no joints, the boulders would not have formed. These boulders, the edges of these things. Edges of these things are eroded, rounded off, and then the boulders form. They slowly creep down the hills. That's how, when you go across the granite hills, these boulders sit on the shoulders of those hills. That is due to the carving of these boulders due to sun and rain over a period of several million years or crore years. Some of these granites are looked at as ornamental stones, and they are cut into blocks and polished and used in the offices and homes. Yeah. Now the volcanic rocks. You look at this volcano. This is the. Let me go from the present volcanoes to the volcanoes in 300, 300 crore years ago or 3 billion years ago, when the Earth's surface was active. So these are all these red dots here. This is the Pacific Ocean, Circum-Pacific Ocean. These are volcanoes. Many of them are active, and they are, when it becomes really furious, it gets reported in the media. This is the Indonesian volcanoes here. Many of them are dormant and are active in the recent geological past. These are the active volcanoes of the Hawaiian Islands, and volcanism is all the time taking place, particularly along the Circum-Pacific belt. And this is a scene from the famous, what we call as the East African Rift. I happened to be there, here in this region. I visited 3 spots in the East African Rift. It's really rift, the continent, eastern part of continent of Africa, composed of Djibouti and the Kenya and the Tanzania. They are likely to be separated sometime in the future, several million years from now anyway. But the activity is already taking place. So this is the active volcano in this part of this one, and this is the Hawaiian Islands active volcanoes here. Yeah. This is an Iceland. I happen to see the volcanism occasionally takes place in this island, Iceland. It is located southeast of Greenland. In 86 and 87, I used to stay there, and before going to the Greenland, we used to stay there to observe the weather conditions in Greenland. So Iceland also is a hot area. It is in the North Atlantic Ocean. It's a hot area. This is the one which we call as the Nyiragongo. Its name is the Nyiragongo volcano. It's a cool volcano. The temperature is not much. The lavas are all, you can go and it's not hot like the Hawaiian volcanoes, volcanic lava. This is a cool, it's a sodium-rich liquid magma. The scientists go and then they even sample these things. This is the Democratic Republic of Congo. In this part of Congo, you see these volcanoes, and we have the further northwards in the Ethiopia, and further northeastwards we have the Djibouti, where the volcanism has taken place. And even today, there are very hot terrains are there where the drifting of the continent is taking place. Now, let's look at these were there even in our part of Karnataka, in Karnataka state. Now, what I have done here, the green here, they are all greenstone belts, or the volcanic belts. All these red ones, they are the volcanoes which existed almost 3 billion years ago or 300 years ago. These volcanoes existed, and because of these volcanoes, today we have so much of iron ore, we have manganese ores, we have the chromite, gold, even the diamond in the northeastern parts here, and the Kolar, for example. There was a volcano here in the Hatti area where the currently operating gold mine exists. There were volcanoes there. In general, all these areas, the green ones, were originated because of the volcanism which took place the 3 billion years to almost 2.6 billion years. That is the period when volcanism was taking place in this part of Karnataka. And similar ones also existed in other parts of India also. This one, there was a sea at that time between 1.8 to 0.9 billion years. There was an east-west sea. That's where the huge limestones, today the cement factories, Bagalkot Cement, and other cement factories near the Kalabgis and parts of Gulbarga, Bijapur, we have and also almost close to the Bidar, this sea existed, and this sea was comprised essentially sedimentary rocks, that is the limestones and sandstones. And similar sandstones exist. We see in the most famous Tirupati Hills. That means Tirupati Hills, there was huge sea was there. Sea existed to give rise to the sandstones. I will come to that. I will show some of those pictures. How do you say that there were volcanoes? How do you say that there were volcanoes in this part of Karnataka? These are the evidences. We have what are called pillow lavas. These are pillow lavas, means like a pillow. You see this here? This is like a pillow. So these are, for example, these are from the Mardihalli, near Hiriyur on way to Chitradurga. You see these things. These are declared as National Geological Monuments by the Geological Survey of India. Similar ones are found in Gadag region. These are evidences of the volcanism that has gone on. Kolar goldfields, their volcanoes existed. Hatti area, that is in Raichur district, in Lingasuguru Taluk, we see this kind of structures. These are the evidences to say that volcanic rocks existed. Besides, the rock compositions also tell us that volcanic rocks and volcanism happened in this part of the earth, that is in the Karnataka part, to 2.6 to 2.8 billion years ago. Now, there were quiet volcanoes and there were explosive volcanoes. This is the picture that I took while going along the railway cutting from Chitradurga to Chelkari. On the railway cutting, you can see this whitish colored brick here. It is a volcanic rock, almost glassy, and there were explosive volcanoes in this part of Karnataka. Now, this is very fascinating. This is not so old. These are the what we call as columnar joints. Volcanism on a very large scale took place around 60 million years ago in parts of north of Belgaum, going up to the Mumbai, Pune, further north also. It's a very widespread, and as far east as Nagpur, it's a very widespread what we call as Deccan volcanism. That happened 60 million years ago, and during that time, off the coast of Udupi or Malpe, along the western side of Karnataka, these columns originated. These columns form by slow cooling of layers of volcanic rocks. So this is in another evidence to say that around 60 million years ago, volcanism happened in the southern India. Yeah, you see this one? This is while you fly from Belgaum towards, or even Bangalore towards Mumbai, you can photograph these horizontal layers of volcanoes. This is how the continents formed. After the continents formed, these volcanic rocks added up to the thickness of the Earth's crust. Yeah, let's look at the sedimentary rocks. We call them as clastic sedimentary rocks. That means what we see as sandstones and the rubble, and in the rivers you see the gravel. They are all called clastic sediment rocks. There are chemical sediments. Chemicals means calcium carbonate is chemical, and we have the iron-rich rocks, sulfide-rich rocks. They are all the precipitation of chemical precipitates in the ocean that has happened. So all these things have given rise to many useful materials which are used in the industries, like, for example, limestone, which is the base material for cement. Iron formations, iron-rich, they are the base material for steel. Yeah, look at these layered rocks. In the entire history of the earth, several times the volcanic rocks and the sedimentary rocks took place. That's this the layering here that we see is it spans the entire history of the earth, right from 3.5 billion years when the sedimentary rocks first started forming. Right today, the sedimentation is still taking place. One of the best evidences I can say is the Himalayan mountains, the rivers flowing down from the Brahmaputra, the Ganges, and major rivers. They are bringing down the detritus or the material from the Himalayan mountains towards the Bay of Bengal on the one side and towards the Arabian Sea. That means sedimentary rocks are taking place even now. Sedimentation is taking place even now in the oceans. And when they come up, the present day oceans become the future continents, just like the primordial or the ancient seafloor has become the present day continents. That is how the cycle keep taking place. The oceans become continents, continents become oceans, or they go down and under beneath waters. So these are the rocks, and then the sedimentary rocks keep up with the evolution of life also now. Starting from the single cell organisms, we call them as the single cell bacteria, and uh, bacteria right up to the huge dinosaurs, which you know, um, which you know, what should I say, um, traveled the length and breadth of the continents here, particularly southern continents, between 66 million years to 200 million years. That's when we also find what we call as ammonites or the Saligramma. It's famous. We keep Saligramma and do prayers to Saligramma, or its technical name, the geological name is ammonite. It is found during this period of the Earth history between 200 to 66 million years. That's when the dinosaurs also existed. Gradually, around say almost 10 lakh years or 1 million years ago, the seeds of the human beings, it all started. The chimpanzees, and then the orangutans, and the striped man, and the human beings, or the Homo sapiens and sapiens. So that means the human beings appeared just recently on the surface of the earth, just about a million years ago. Yeah, like that. So this is the illustration to say that the earth's crust, within the earth's crust, the sedimentation or the sedimentary rocks are all constantly originating, and they are preserving the fossils of that particular period, or the life organisms and the life forms of those periods are preserved in those rocks. That's how we call this as the scientists have been able to work out how the life evolution of life began. Many of you might have read Darwin's theory of evolution. Okay, now let's go to the oldest sedimentary rocks. Where do we find the oldest sedimentary rocks? In Karnataka. Karnataka, we find the oldest sedimentary rocks here in parts of Chikmagalur. Before entering from Hassan towards Chikmagalur, you can see there is a ridge, east-west ridge. You find the pebbles like this. These are the pebbles. They are quartz pebbles. They are the first signatures in the sedimentation that has happened over 3 billion year rocks. They are the signatures of the first sedimentary rocks in part of Karnataka. Similar ones have happened in other parts of India, also parts of Singhbhum region and parts of Rajasthan and also central India. Now, let me take this example from Karnataka, because we are in Karnataka. Yeah, these are the thin layered the sedimentary rocks. These are beds of iron oxides. Huge deposits of iron oxides can be seen in parts of Sandur, near Hospet, and the Bababudan Hills, the Kudramukh Hills. We have got what's called banded magnetite quartzites. They are also iron ores. Then the Bababudan Hills. Now the mining is prohibited in Bababudan Hills to preserve the biodiversity in this region. Otherwise, there are huge deposits of iron ore there. Initially, when the Bhadravati ironworks began, the iron ore used to come from the Kemmanagundi for that region. They are all chemical sedimentary rocks. Then the Sandur Hospet region is another major the resource of iron ores in Karnataka state. So now these are boulders, like the way we see the boulders within the river beds. The bigger the river, bigger the size of the boulders. From a small silt sand size to going up to 1 to 1.5 meter boulders can be rolled down by the rivers. So rivers carry even the geological past, the several times in the geological past, up to almost 3 billion years, such rivers existed and they moved boulders, and we call them as conglomerates. These are the photographs from Gadag region, and there are similar ones in part of Kolar goldfields area, Hatti goldfields, Sandur, and also in parts of Bababudun, near Shumaga. There's a place called Kaldurga. They are the famous boundary conglomerates. All this are in evidence of rivers carrying the sediments, the boulders into the ocean at that time. Yeah, these are chemical sediments, or the sulfide-bearing chemical sediments along the western margin of the Kolar, what we call as the greenstone belt, volcanic belt. Yeah. Now, moving to a slightly younger period of time, between 1.6 to 1 billion years, we had sandstones. I already referred to the region, Bagalkot region, and also in parts of Kusti, and there are sandstones and limestones are found. That means there existed a ocean. It's almost like northeast to southwest or east-west oceans existed, in which deposited sandstones and limestones. Yeah, these are. You can see the sandstone here. It's a outcrop. You can see the sand grains here. Exactly similar ones are found in the Vindhyan mountains and the Tirupati range of hills. These are the places where the oceans existed. And you can see this here. These sandstones of 1.6 billion years are deposited over 2.5 billion year granites here. See, these are the sandstones. These are the wave action, what we call as the cross-bedding. I will show much more spectacular outcrop here. You look at this one here. These are the seashore, the waves coming from the ocean side towards the continents. They deposit the sand in this thin layers. Each wave deposits a thin layer of sand. This rock, what we call as cross-bedded sandstones, they preserve how the wave action was operating in those times. These are Maralu Shilagadu, cross-bedded sandstones. Yeah, these are the limestone beds here, and here is a highly weathered one. But in the parts of in our Belgaum, Bagalkot, further east, they are very well preserved limestones. They are very fine grained limestones, which supports the cement factories today. Yeah, these are some of the and as I said, iron formations. These are essentially cherty iron form. Chert means fine grained silica. You see, look at this. They are almost a millimeter size. They are all folded. Why they are folded? Due to the dynamics of the earth. They were due to pressures acting in the crust of the earth. They were folded. I will come to that. I'll show how I've explained how the folds form and how the mountains are formed. So this is one of the examples of a chemical sediment which is folded up. Yeah. Look at this one. This again. These are the white ones are all silica layers or the quartz layers, and the reddish ones are iron-rich layers here. Yeah. Look at this. See, the same thing is a mountain here. So this should give you an idea due to the compression in the Earth's crust, due to the compression of the sedimentary rocks and the layers of volcanic rocks and sedimentary rocks, mountains form. Okay, so on a small scale, when we are going, a geologist goes in the field and looks at the rocks. On a small scale, you see this kind of a thin, what we call as planar fabric, we call like a sheet or like a book. These are formed due to the pressures acting on those rocks and due to the pressures created in the earth. Yeah, and they are also folded on even small scale, on an outcrop scale, or say table scale. Yeah. So now, here, as I referred to in the very beginning, I said there were volcanoes here, and these volcanoes and sedimentary rocks that formed 2.5 to 3 billion years ago in part of Karnataka, they are all folded. If I say, it should surprise you if I say that these mountains 2.5 or 250 crore years ago were like the Himalayan mountains. Okay, here look at this one. It was initial oceans were like this, like the present day oceans. Volcanism took place. Layers of volcanoes deposited. Layers of sedimentary rocks formed. Sedimentary rocks eroded from the volcanic rocks and the then existing continents. They deposited the detritus into the ocean. They accumulated to huge thicknesses of the order about several kilometers. Then the Earth, due to the dynamics of the Earth, due to the movement that is taking place at around say 60 to 70 kilometers below the surface, these what I called as plates of rocks, they are the continents and the oceans started moving, created these mountain ranges. See, from here to here, about 60% of the rocks are compressed, about 60% from their original horizontal layers to their compressed nature. So it means from here to here, let's say is about 400 kilometers. It was almost nearly 6 times larger in early part of the Earth history, 350 crore years ago. That was a dimension. They're all compressed into mountains. That's how we see these layers of these rocks spread over in north-south direction. Here, they're all folded mountains. Okay, and due to look at this one here. Look at this. If you put a thread here and go take this along with here and open it up, it becomes, say, if it is say 1 meter, it is 6 meters when you spread it. Okay, that means about 60% compression has taken place. So original rocks, horizontal rocks, were compressed to that extent. They became mountains. So these are the evidences for the compression of the rocks. Yeah. Now let's look at the minerals and metals, how they formed. See this periodic table here. All the elements, 85% of them that you see here in the periodic table, they all are formed inside the Earth's crust. They all formed inside the Earth's crust. So all these metals, I'm not going to read them because of lack of time, and all of them are very important, right? From hydrogen, lithium, sodium, magnesium, calcium, scandium, and then iron, cobalt, platinum, gold, and all this what we call as the rare earth elements. Everything originated, and almost all the metals are being used by mankind in one way or the other. And the utility of these metals began with the developments in science of how to use metals and metal alloys in various gadgets, and particularly with the advent of electronics in the last almost 40 years, many metals which were not being used in the early days are being used. Almost all the metals you see in the periodic table, they came, it should not surprise you, they came from the bottom of the earth through volcanoes. Yeah. Now, iron and steel, for this is particularly for the students I'm telling, and iron and steel, they come from iron ores. Okay. Then iron ores are required for not only production of iron and steel, but also for many other uses that I'm not going to touch upon. And steel is an alloy of chromium, and to produce steel we require many other minerals like coal is required, lime is required, bentonite, fluorspar, these are required, and to heat them up to molten stage, we require what we call as refractory bricks and tiles formed of graphite, kyanite, andalusite. They're all the aluminum silicates which can withstand high temperatures. So titanium and titanium alloys, they are used for high temperatures like the surfaces of the rockets because they have to withstand temperatures to the order of about 3,000 millimeters. Sorry, 3,000 degrees centigrade. So the titanium is required to be mixed with the iron ore to form titanium steel. So molybdenum, vanadium, molybdenum is required for molybdenum steel. Likewise, vanadium, these are all for different, even niobium steel for high temperature steels. Copper, lead, zinc, cadmium, cobalt, lithium and cobalt, they are required for electric vehicles. That is, all these years we have been, even today and for some years to come, we are going to be dependent upon coal for our energy requirements, power requirements, and the diesel and petrol for running the motors and the vehicles. But in the future, India has decided to transform or to move over to the non-fuel power generation, non-fuel the technologies for running our vehicles. So they are called EV, electric vehicles. Cobalt, lithium, nickel are all required, including graphite. Uranium and thorium, you're all familiar. Uranium is used for generation of power. Uranium is a radioactive element. So the uranium generates the heat, and then it produces the power in the reactors. So uranium, thorium are required for nuclear power generation. And then the gold, silver, diamond, they are the ornaments. Platinum has got number of uses, not just in the ornaments. And these are also used in the computers alongside the rare earth elements. We use these metals in the computers, telephones, mobile phones. About a few milligrams of these gold and platinum are used in the electronic gadgets, in printed circuits. We also use them in satellites. Bauxite is required for aluminum manufacturing, paint manufacturing. Micronized varieties for the paints. Varieties is barium sulfate, and these are the base materials for paint industries. Even the micronized in the sense the limestone which is ground to micron scale. Micron means there is 1,000 microns in 1 millimeter. That is the fineness. And we have the titanium dioxide. These are all used in the paint industry, specialized steels. For glass making, we require sand, fine sand, essentially silica sand. Ceramic wares uses the potassium aluminum silicates. Gypsum. And for fertilizers, we require gypsum and the phosphorus, for what we call as phosphorites, that is phosphorus. We also require for even toothpaste, talcum powder for face powder. So what does this mean? This means from morning to evening, throughout our life, everything, we depend so much on the minerals. Without minerals, we can't think of our existence. Everything today, we are using these gadgets. They contain not less than these two, a laptop and a desktop. They contain in our mobile phones not less than 27 metals, like that. So all these things come from the bottom of the earth. So buildings, all our buildings, without steel, without cement, without brick, this is the we must appreciate that these are everything that we use come from the surface, from the interior and surface of the earth. Water also, in the very beginning, it came from the earth, from the bottom of the earth, from the mantle of the earth, and now from the heavens. Yeah. Now, I'm not going to read this. This is a very, very important one. Rare earth elements and rare metals. Today, China controls the world. 80% of these rare earth elements. Rare earth means, you saw it. We call it as about 14 elements. Lanthanoids, we call them as lanthanum, cerium in the periodic table at the bottom. These have got special qualities, and a small quantity of them is used. For example, this red color here, without this red color can only be obtained by using one of these metals here, rare earth metals. Without that, we can't produce the green or blue or reddish color on the screens here. These screens are made up of rare earth elements. Our TV screens and computer screens and mobile phones, these are called modern high-tech metals used in aerospace industries, the satellites and the defense systems. Yeah. Now let's look at this, how they form. This is the surface of the earth. Most of the volcanic rocks, they erode, that too particularly iron rich and magnesium, manganese rich volcanic rocks. They erode on the surface of the earth, and they supply or deposit their contents along the continental shelf and also into the deep ocean, mainly along the shore and the continental shelf. They give rise to, after several million years, they become the continents when they occur as iron ores, manganese ores, chromite ores, limestones. These are the sedimentary rocks that originate due to the erosion of volcanic rocks on the surface of the earth. Other metals like gold, diamond, chromite, platinum, antimony, and all other metals which I referred to, even tin, molybdenum, tungsten, they all comes from the 20 to 40 kilometers, and also below that almost 100 to 275 kilometers. From the deepest part of the earth comes the diamond. Diamond is stable only below 275 kilometers. So you should know that when you buy a diamond, the diamond is originated 275 kilometers below the surface of the earth. You may, it will surprise you how it came up from 275 kilometers. Definitely, they came up only through volcanoes. These special rocks called kimberlites were brought up from 275 kilometers to the surface of the earth. That's how we find diamonds on the surface of the earth. And then many of these, what we call as hot springs, geysers, brought up sulfurs. Sulfur, when they combined with other elements like iron, they gave rise to iron sulfides. When they combined with copper, they gave rise to copper sulfides, zinc sulfide, lead sulfides. And lead sulfide, when you break it up, it becomes lead that is used day to day. So that is the process of obtaining the metals from the ores. These are called ores, O-R-E-S, or minerals. Lead sulfide is a mineral we call galena, and the sphalerite is what we call as zinc sulfide. So there are several names for these things, and those are called minerals. From minerals, metals are extracted. But in the case of gold, gold occurs as it is in nature. 90% of the gold that we mine, they occur as it is in the surface of on the surface and below the surface of the earth, as it is. Yeah. Now let's look at this one. Let's go back to what is called the continent plates on the surface of the earth, oceanic crust or the oceanic plate, and then the continental plates. Continental plate is, for example, the Indian subcontinent here. It's a plate. It's moving towards the Himalayan region at rate of 5 centimeters per year. I say these are the plates that existed from the beginnings of the earth in different dimensions. When the plates were moving, the oceanic plate, when it subducted or went below the continental plates, it triggered at certain point due to the prevailing temperature. It began melting, and when the rocks melt, it increases in there. They expand due to the presence of water. They expand, the volume increases, and they try to come out through the fractures in the continents. That's how this illustrates here. For example, here the melting has taken place here at around, say, 50 kilometers depth, and it came up through a volcano through the continental crust. While coming up there, what happens at the end of the crystallization of rocks, there will be fluids rich in these metals. Those fluids rich in metals, they fill up fractures within the crust of the earth, within the first 5 kilometers to almost going up to 8 8 to 10 kilometers, the fractures will be filled with these metalliferous fluids. That means metal-bearing fluids, or they come up through the fractures and deposit their contents. That's how we have the metal deposits today, and for the benefit of mankind. These are all God-given, I can say. How all these things, it all surprises how all these things formed. There is a design which we can say God's design, and of course, scientific theories are there to explain how all these things are formed. But primarily, how it all began, we have to really salute God. Yeah. See here, this is a cross section of the Earth's crust. See, let's assume that this is the point around 275 kilometers. This is how a kimberlite carrying a diamond comes up to the surface. Here is, for example, a quartz-rich fluid bringing up gold. Likewise, the fluids bring up the lead sulfides, copper sulfides, zinc sulfides. All these metal sulfides and metal oxides are brought up through in the form of fluids to the surface of the Earth and deposits in the fractures. Even now, today, here in the bottom of the oceans, here, what are called black smokers. That is, there are hot springs are there below the oceans. All these red spots here, they are all hot springs. That is at the bottom of the ocean. This kind of hot springs existed in the geological past also. That's how we have these metal fluids. So once we exhaust all these metals on the surface of the Earth, definitely we go into the oceans to start mining. There's huge resources of all these metals, including copper, lead, zinc, platinum, and also gold. All these metals are also found in the present-day oceans. We cannot mine them because it's very expensive. It's not profitable. Otherwise, a time will come, maybe 50 years from now, surveys are already taking place. The human beings will start mining the ocean floors. Yeah. For example, here on the surface of the Earth, there is a place called Lake Assal. I was working in Djibouti here, in Northeast Africa here, in Djibouti. And from here, I went to, across the desert, I went to Lake Assal. This is the Lake Assal here. This is a Google image. You can see this Lake Abe and Lake Assal. I think I went to Lake Abe, correct. This is the place I went. You see the hot springs there. They are accumulating the silica in the form of silica gel, and also calcium carbonate, magnesium carbonate. Even some of them carry copper. Some of them carry small amounts of platinum, and also zinc, lead. These are all coming up. Being a geologist, I was very curious how these things form. So I drove one fine morning 3 o'clock. I left from Djibouti, drove around 250 kilometers towards Lake Abe, and this is what I came across here. That was an adventure trip. I had a very good driver, very bold driver, local from Djibouti, who speak English, French, and Afar languages. Yeah, here it is. See, look at this obelisks of calcium carbonate with iron hydroxide and iron sulfide, and also silica. This is the metals forming today on the surface of the Earth. These things have formed in the geological past, and they are forming even today. This is a place, Lake Abe, between Ethiopia and Djibouti. This is a sulfur spring. See, look at this sulfur. When sulfur combines with iron, they become iron sulfides. Copper sulfides. These are the other crystalline. When there are cavities inside the Earth, these fluids, they crystallize slowly, just like we can develop crystals in the laboratory. These are the crystals that are formed inside the Earth's laboratory. Earth is the biggest laboratory. You cannot have any bigger than that one. Everything that you can create, you are creating in the lab today, they are already created by nature inside the Earth. Fantastic. There are thousands of varieties of crystals that are seen, that are formed inside the Earth. Each one of it has got different chemical compositions. it is beyond the scope of today's talk to deal with them individually. Now let's look at India, from where all of us are using several metals every day and where they come from. Let's look at initially iron, manganese. I have already told you where they in Karnataka, where iron ore, manganese occur. Let's touch upon that. In Chitradurga area, along the western margin of what we call as Chitradurga belt, in parts of Chikkanaikanhalli and parts of Tumkur, and right up to the western part of Bhimasamudra, we have got iron ores and limestone. And in parts of Sandur, that is near Hospet, huge iron ores are there, which are being mined today. And also Hundgund area, iron ores are there. In parts of Goa, we have got iron ores. We have got huge iron ore deposits in parts of Orissa. Really, they are very big, bigger than in Sandur region near Ballari, and in parts of Jharkhand, in Chhattisgarh here, south of Raipur, we have the iron ore mines, large iron ore mines. Similar to that, we have some small iron ore mines in parts of the east of Jabalpur in Madhya Pradesh. There are small mines even in parts of Rajasthan also. So these are, and bauxite along the east coast. We have the bauxite along the west coast of Karnataka. We have bauxite, Paduvare, Plateau, and other places. Bauxites are there. Bauxite is the main ore of alumina. In parts of Orissa, we have got bauxite, and these are the places where bauxite is the ore of alumina is being mined. Okay, now this is a scene. This is a part of one of the mines in the Sandur Hospet sector. This is a hematite iron ore containing 67% iron, Fe. And so iron ore has to be split in a furnace, adding coal, and becomes iron metal as it is, and it will be the base metal for steel production. Okay. Now the diamonds, very interesting. Now, by the way, I must tell you, Indians are the pioneers in the world in metallurgy. Today, iron ore, steel was produced. Believe me, steel was produced in Karnataka. First time in the world, it is in Karnataka. Steel. You have heard of Damascus sword? Damascus, the base material, metal, that is the iron. The use for Damascus swords was originated from South India and also near Hosdurga, Karnataka. So we were the pioneers in the world for production of steel. And the Qutub Minar, it doesn't rust at all. It's a steel which has withstood oxidation. You see, so India is a pioneer. Diamond. India was a diamond. The diamond was discovered here in India, and India was the first to use diamonds in the world. Indians knew how to put. Diamond is the hardest of minerals. 10 its hardness. To put a hole in the diamond, only Indians knew. How they knew, I also don't know really. But I know that diamond was first mined in the world in part of Andhra Pradesh, in a place called Kolluru. They are called as the Kolluru diamonds. The great Mughal, the Kohinoor, the Regent, the Nizam, and Orloff, they were all placer diamonds from the Krishna River Valley near Kollur. And even now, diamond is definitely there, and it's a question of exploring them. Many have explored, including National Mineral Development Corporation and some of the private people. The diamonds can be mined. There is only one diamond mine today in India, that is in the Panna diamond mines near Khajuraho. Panna diamond mines is an active diamond mine in India, which is nearly 80% of which is all what we call as industrial diamonds. That is a diamond that is used for drilling purposes and like that. But there is one recent discovery by a foreign company called Rio Tinto. It discovered near Bundair, in not very far from the Panna diamond mines. One of the best quality diamonds they discovered, and Madhya Pradesh government may throw it open for mining in the future. So there are still today the mining is being done by artisans near Panna. So these are all world famous diamonds were produced or mined in India. Yeah, these are all the places. You have heard of Khajuraho here. Near Banganapalli and Vajrakarur, diamond was being picked up in the early days. Even near Jannagiri or Honagiri, near Gutti, diamond was being picked. This is the Panna, famous Panna where mining is going on today. And Hirakund, Hira means diamond, Kund means mine. They are the places where diamond was mined here, Vairaghar. So, and then this is the world famous diamonds came from Kolluru. This is the Kolluru here. Okay, here, Krishna River Valley. This is the place. Yeah, these are the places where diamonds are found. The most world famous diamonds, or what we call as pink diamonds, come from the Western Australia here. Here, this is the place where the pink diamonds originate. Other in South Africa, there's Kimberley is most famous for diamonds. The mines have gone down to, I think, almost 3 kilometers depth. The gold mines too there have gone down to 4.2 kilometers depth. I will refer to you in some other slide. So these are the places where diamonds are mined, and India, these are the places where diamonds are found but mined only at one place in Madhya Pradesh. Now let's come to my pet subject, gold. These are gold occurs in all these places. We call them as cratons. Cratons are those places which are 2.5 billion years old or 250 million years old. 2,500 million years or 250 crore year old. Look at this one. Karnataka is that not without reason. Karnataka is called Chinnadanadu. That the reason is the gold was mined here almost 10,000 years ago. 10,000 years ago, the modern mining of in India began in Kolar gold fields almost 150 years ago. Systematic mining began in Kolar gold fields. Almost the same time in Hatti gold fields also here in this region. Here. So gold is found, let me use this to explain that gold is found in parts of Karnataka, Andhra Pradesh, in parts of Chhattisgarh, and then Chhattisgarh and eastern Maharashtra, in parts of Jharkhand and Orissa, and in parts of here, the Madhya Pradesh, Western UP, and Madhya Pradesh here, and Rajasthan. Rajasthan recently, in the last 25 years, a place called Bhukia, there 240 tons of gold has been discovered by the Geological Survey of India and a private company, mainly by Geological Survey of India, and that is near Udaipur, south of Udaipur. So there is a lot of scope for development of gold mines in the country. The current Indian policy is not so good, really. I should say I have been criticizing it. It's not supportive of some of these metal mining. So there is a lot of scope for the development of not less than 200 gold mines in the next 5 years. It is possible. Look at this sample. This is how gold used to occur in the Kolar gold fields. There is a saying that in Kolar gold fields, gold used to be picked up by nuggets used to be picked up by buckets, so to say. Yeah. See, this is a geological map of Karnataka state, and this is the famous Kolar gold fields, this is the Hatti gold fields. And in this part, this was my discovery in Ganajur. In 2003, I discovered. Today it's about 15 tons of gold is there, and there is potential. And also north of Dharwad, here, the place called 11 kilometers north of Dharwad, Mangalagatti and Bhavihal. These were also my discoveries along with my colleagues in Deccan Gold Mines Limited. And the Geomysore Services is currently planning to mine a place called Jannagiri. It's about more than 20 tons of gold is found in Jannagiri. This is in Kurnool district of Andhra Pradesh, about 300 kilometers north of Bangalore. These are the places where we can develop gold mines in Karnataka and parts of Andhra Pradesh. Yeah, this is how gold occurs. You see, I was talking about veins filling up fractures in the beginning of my talk somewhere. They are gold veins filling up fracture. This is how gold occurs in nature. on a small scale. This is a hand specimen. Look at this. Fractures are filled with gold-bearing solutions, and these are, when these things fall off into the streams, they become nuggets like this. These nuggets and particles are mined by what they call artisans. Even today in Gadag region and also in Suvarnamukhi river in Jharkhand, the people mine gold or pan the sands and for their livelihood, day-to-day livelihood. Even today it's going on. Yeah. See, Western Australia, just for a comparison, we know today we have about nearly in Karnataka around 300 tons of gold is known from various points, most of which is locked up here in Hatti, in Raichur district, Lingsgur Taluk, and here in Kolar area. Compare this to Western Australia here. There are number of more than 400 to 500 prospects and mines exist in the part of Kalgoorlie. I have seen most parts of about 4,000 kilometers I have traveled in parts of Western Australia, right from Kalgoorlie, Northman to Wiluna here. Perth is here along the west coast. Perth is here, staying here and traveled number of gold mines and top. Karnataka and India can become Western Australia provided the Indian policy is opened up and allowing everybody to file applications and go for mining. And people should be, the law should be so convenient for attracting investors to start gold mining. And there is a lot of scope, I tell you. Yeah, this is the Ganajur, which is the Discovery Hill, 2003. When I was along with my colleague, Dr. Harish Kumar, we were traversing this area when we came across gold in this part. And now the gold occurs inside, below this ground, 3 meters of soil for almost 1 kilometer depth. So Deccan Gold Mines Limited is planning to mine this area. Government of India has given the approval already. Yeah, this is a place called 11 kilometers north of Dharwad. This place, there is already an ancient working here. We all, without a helmet, we risked our life, went into this cave to collect some sample and to see whether gold exists or not. This is a place called Mangalgatti. And this is where in Jharkhand, I used to collect samples from these son jharias, they are called. See the gold nuggets, and this is the gold particles that they pan, and they get, say, 0.1 gram. For example, today, if they get a 0.1 gram today is 1 gram is 4,000 rupees. 0.1 gram is 400 rupees. Even if they sell it at 200 rupees, they make their life, they live 200 rupees per day. And that's how they are making living in this part of part of Jharkhand, and then southeast of Ranchi, and in part of Chhattisgarh. Chhattisgarh means south of Raipur. That's where there's a place called Sonadehi. That's where the panning was taking place when we were exploring that area. Okay, this is from eastern Zambia. When I visited that one, local hundreds, thousands of people are dependent on panning in the rivers for gold. Yeah, here, this is eastern Madagascar here. When I was exploring this region, not very long ago, 2017, 2018, this man is showing visible gold in picked up from here. They dig and then pan for gold. Gold has high specific gravity. 19 is the specific gravity. One of the heaviest metals. You can easily separate gold from the rubbish or the gravel. In nature, this is how tungsten occurs in the Hatti gold mines. See here, it glows when the UV lamp. When you take UV lamp, it glows. It's tungsten, what's called scheelite. It's found along with gold. Within the mine, you find fractures filled up with gold particles here, like this. Okay, this is from Janagiri. Gold occurs within the quartz. Yeah, Kolar gold fields. As I said, the first mines were leased by the Maharaja of Mysore to the Britishers. There were not less than 90 mines in the about say 10 to 15 not 10 to 15, almost 80-kilometer tract right from Srinivaspur to the Bangarpet, Kolar Goldfields to Kuppam Taluk, right up to Krishnagiri. Gold mines existed 100 years ago, 150 years ago. This was one of the famous shafts, a single well-like feature, a shaft. It's a hole in the ground going almost up to 2 kilometers depth. 800 tons of gold has been mined, most of which were taken away by the Britishers to London. Yeah. Okay, now copper, lead, zinc. These are the places. Very famous mines. Copper mine is in Malenjkhand in the Balaghat district here in Madhya Pradesh. Yeah, and then there are mines in the Singhbhum region here. Singhbhum is near Ranchi, all surrounding Ranchi, southeastern part of Ranchi. There are uranium mines also exist there. Copper mines, most of the copper mines. Khetri is a famous copper mine, and as I said, Malenjkhand is a very large open pit mine. Now being underground, they are going below the ground. Its surface is exhausted, and in parts of here, what's this? Udaipur. In parts of Udaipur, we have famous lead mine, a place called Zawar Mines, and there's another place called Rampura Agucha, which is being mined by Hindustan Zinc Limited and Vedanta Group. They are mining one of the richest lead, zinc, silver deposit is Rampura Agucha deposit in Rajasthan. Here, Ingeldal, was an early mine. Ingeldal was a copper mine which began in 1965, 66, 67, and that's where even the Vijayanagara time and the Tipu Sultan time there were copper mines in this area. And later on, under the leadership of the then director Dr. B.P. Radhakrishna, Padma Shri B.P. Radhakrishna, the copper mining began at Ingeldal, just about 8 kilometers south of Chitradurga. And there are also Karnataka Copper Consortium, an undertaking of the government of Karnataka began. They started mining at Kalyadi. Kalyadi has got a lot of cobalt. Cobalt is a very important metal for green energy technology. The Kalyadi copper is now, I should say, it is going to become cobalt mine in the future. It also, these are suspended at the moment, but they have the scope to be revived. They can once again become copper and cobalt and gold mines. Small amounts of gold also are there. South of this one, Ajjanhaddi, that's where the gold was being mined, and a lot of gold has been discovered in the recent past by the Geological Survey of India. All in all, Kolar is known for zinc, but its mine is yet to be revived. So, in parts of Rajasthan, Maharashtra, and Karnataka, copper, lead, zinc are found, cobalt, tungsten. Malenjkhand is a very huge mine. It's open pit mine. This is the surface. You see, now it's going underground. Yeah, this is the. You see, look at this one. Rampura Agucha lead, zinc, silver mine in Bhilwara district of Rajasthan. This is the Copper Mountain, or what we call the Belligudda. That's where I started my career as a mining geologist here in Ingeldal, Halu here. The Kitta we call, or the slag heaps were there. That's how the village name Ingalada Halu, like that. So then the platinum is not being mined in India, but there is a lot of scope for development of platinum mines in parts of Sukinda, along with the chromite, Bola Nausahi chromite mine in Orissa. We can start, platinum can be extracted. In a place called Purushottampur, my colleague, Dr. Harma Prasad, discovered platinum here in this region, in parts of Chhattisgarh. Here in Bairapura, there are signatures. There is a place called Hanmalapura. There are signatures of platinum, and along with the chromite in this region. More famous is the Sittampundi here in Tamil Nadu. Here, platinum is made. Platinum, rhodium, and palladium are found. Sittampundi has the potential to become a platinum mine in the future. Yeah. Uranium minerals. The most famous uranium mineral is the Jaduguda in the southeastern part of the Ranchi here, and that is the mine that is being one of the mines, and the other one is Tumalapalli in the Kadapa district in the southern part of what we call as the Kadapa Basin, and that's where uranium is found. And uranium is being mined there, and we these are some of the uranium minerals. You see, look at their bright, beautiful colors. Uranium is one of the most sought after mineral. India has got, fortunately, a good amount of resources are there. One of the recent discoveries of uranium is in the Gogi. My colleague and classmate, Dr. Achyuta Pandit, was the discoverer of, when he was serving the Atomic Minerals Directorate, he discovered the Gogi uranium deposits in Gulbarga district. It has got a high grade. It's a high grade uranium. It is, I think, the government of India is planning to, Uranium Corporation of India is planning to mine it. There may be developments going on there. Yeah, this is the Jaduguda uranium mine. Most of the uranium and copper occur together here. Ranchi is somewhere here, and this is the whole belt has got the potential to become, for expanding into copper uranium zone. Yeah, coal is the hot subject now. The government of India has opened up coal deposits to be mined by entrepreneurs. Coal blocks are being auctioned. Recently, 41 blocks are thrown open for investors to pick up. These are the lignite mines. This is one of the very famous lignite mines discovered by Dr. M.S. Krishnan, one of the very famous Director Generals of the Geological Survey of India, and a very large lignite mine that is operating. And some parts of here, Gujarat, lignite is being mined. These are the most famous coal fields in India. India has got very large resources. Stated it's about third or fourth largest coal deposits occur in India. But we should be mindful. There's a Paris Agreement is there. All the nations should put efforts. Even India is putting its efforts to move on to green energy technologies over a period of time. All fossil fuels, coal, the diesel, petrol, they are going to stop burning them in the interest of protecting the environment. Yeah. Now, I will not take much time. I think I have overshot my time. I'll just, our PGR Scindiaji was kind enough to mention about my field trip. I think only about 3 or 4 people from India have visited Greenland. One of them is another Bangalorean by name Deepak Bellur, grandson of one of the most famous directors of mines and geology, Bellur Ramarao, his grandson. He visited Greenland. Earlier, Dr. Ramakrishnan, one of the most famous scientists and geologists from India, he visited Greenland. I happened to visit Greenland twice as a scientist in an 8-member team. This is the broken up North Atlantic Ocean. This is the area. This is the place, Almasalik, I visited. I also flew down to the westernmost and northernmost airport here, a place called Sondre-Stromfjord here. The North Pole is somewhere here is the North Pole. Now, why the Greenland is called Greenland? It's actually white land. The 85% of Greenland is all covered with almost 3 kilometers thickness of ice, permanent ice, hard bluish ice is there. The reason is in the southern part, in the month of summer, when it was free of snow, this was noticed by an Icelander. He saw and cried. He shouted, Greenland, like that. That's how he saw the southern tip of Greenland where there was green grass. That's how Greenland became Greenland. Otherwise, it should have been white land. So this is the summer months in July and August. July particularly, we have 24 hours daylight. We used to work up to almost 12 midnight. So this is how the snow-free or ice-free surfaces, which is exposed in the months of July and August, summer months, the temperature is 9 degrees centigrade. and general temperatures are all minus 20 degrees to minus 20 to the 30 degrees. It's very difficult to get water there. We have to hammer the ice and then ice covering streams there, hammer them and get into water, collect water. So without helicopters, I'm here. My pilot is reading some books, and I'm just about to begin my field work here in this region. Okay, this without helicopter we can't go in Greenland. This is one of the places I was photographed by the pilot. Yeah, look at this one. Why Greenland? The Greenland has got a lot of similarities for Karnataka state. The rocks that found here are found in Greenland here. Same similar rocks, similar formations. They are all exposed. You look at this, the inclined rocks here, banded volcano sedimentary rocks exposed in this place, southeast Greenland. Same kind of what is called granitic gneisses that we see in parts of Bangalore, southern Bangalore, and parts of the Kanakpura, Namnagara areas, Kolar. These are the kinds of gneisses, and further down south into Krishnagiri district, we find such banded rock. All are found in Greenland. You look at this iceberg here. See, fantastic scenery. We used to use this what's called kayak. They are all Eskimos using kayaks. We were giving rubber dinghies or rubber boats, silicon rubber boats. We have to learn it within just 2 days to go around in the ocean. And it's very difficult to find just 10 feet by 10 feet area to land our helicopters. This is landed precariously because I wanted to sample coming down here. So the pilot obliged to land here. Glaciers, thousands and thousands of glaciers bringing detritus to the North Atlantic Ocean. Gentlemen and ladies and gentlemen, students and teachers, I am grateful to all of you for your patience. And I once again thank Bharat Scouts and Guides, especially our dear PGR Scindia ji and Madhusudan. I thank you both. Thank you all. Over. Thank you, sir. I think I overshot my time.
Sir, thank you very much for this wonderful session. We have thousands of people who are watching this session throughout the country. We have people from Orissa, Delhi, Chhattisgarh, Rajasthan, and the lion's share goes to Karnataka. And one of the popular requests from many people is, ದಯವಿಟ್ಟು ಸರ್ ಮತ್ತೊಮ್ಮೆ ಈ ವೆಬಿನಾರ್ ಅನ್ನು ಕನ್ನಡ ಭಾಷೆಯಲ್ಲಿ ಮಾಡಿ ಅಂತ. We request you to come again and present this webinar in Kannada. Might be whenever you're free, you let us know, sir. Our viewers, guides, rovers, rangers, they are very much impressed with your knowledge and information that you have shared. I was following quite a lot of comments and which said, in Karnataka, we have so many things namu gottirlilla. Kannada Nadu, Chinnada Nadu anta sumarashtu jana message madidare, sir. This is going wonderfully well. And on behalf of Bharat Scouts and Guides Karnataka, I take this opportunity to thank you. And I thank all the viewers who have been present and patiently listening to this wonderful piece of information what you have given. And we will come back, and I promise all our viewers that we'll bring back Dr. Vasudev sir in front of you with a couple of different topics. One is he can give a session on one of the rare metals in the world. He can also talk especially about gold. So we will bring back sir with different subjects and topics. And thank you everybody for this, and we will come back to you on the 16th of July at 10:50 a.m. in the morning, where you can see one of the person who put Bangalore on the global map. Mr. N. Narayan Murthy, the founder of Infosys, will be here on the same place, same page. So see you all on BSG Karnataka on 16th of July, along with Mr. M. Narayan Murthy. Thank you, one and all.
Thank you very much. Thank you. Thank you. Thank you much.